So in this video, we want to discuss the idea of global extrema. This was an idea that would have been introduced to you in a pre-calculus class, but we want to go ahead and re-look at it in the context of a calculus course. So we'll first go over the definition, and then on the second slide, we're going to show some graphical examples. And my pen just turned off on me, so I got to turn it back on. There we go. So we want to talk about a function f of x, and we want to define that function f of x on some interval that contains an input value c. So at the interval, we're talking about establishing a working domain for your function. The interval can be open, it can be closed, it can be a half open interval. So for example, we could be talking about the interval from 5 to 7 that doesn't include 5 and does include 7. So define f of x on some interval I. It doesn't matter what the interval is on which you define it. And then we want to talk about an input value c that exists in the interval. So for example, 6 is an element of the half open interval from 5 to 7. So 6 could be your value c. So c is just you define an interval, and c just needs to be some value in that interval. And what we say is that the output, f of c, so when you put the input into the function, you get an output. And we want to say that the output of the function, f of c, is a minimum of the function on that interval if f of c is less than or equal to all of the other f of x. So if the output is the smallest it can be on that interval, then we say that we have a minimum. Likewise, if f of c is the largest it can be on that interval, then we say that we have a maximum. So if f of c is greater than or equal to all other function outputs on the interval we've defined, then we have a maximum. And the minimum and the maximum on an interval are called the extreme values on that interval. So we say extrema or extremum if it's singular. And so you're going to see this thrown at you in several different ways. You can be asked to find the minimum value. You can be asked to find the absolute minimum, the global minimum, or minima if it's plural. And you can be asked to find the maximum of the function, or the absolute maximum, or the global maximum. So these are synonyms for you being asked to find on a given interval, is there a largest or smallest function output? So graphically, we can talk through some examples. So if we're looking for global extrema, the largest or smallest possible output on an interval, first you look at the function you're working with. So here I have a parabola opening upwards, and the GeoGebra convention is that there are arrows there. And so this function has been given to me over the open interval from negative infinity to infinity. And when I look at it, I see that I have a low point or a minimum on the function. I can see that f of 0 equals 1. And this is the lowest point on the function. So this is the smallest function output that's possible. So this function has a global minimum, smallest output, at the ordered pair, input 0, output 1. And the minimum value is the output. It is the 1. The f of c is the minimum. So f of 0, in this case c is equal to 0, f of 0 equals 1 tells us that we have a global minimum output of 1 on the open interval from negative infinity to infinity. But when I look at a global maximum and try to find that, I don't get one. So what I want to notice is that if we take the limit as x goes to plus or minus infinity of the function outputs are going to infinity. There isn't a real number largest output value that this function gives me. So this function here has a global minimum of 1, but no global maximum. Here I have a parabola opening downwards. So in this case, the domain over which I've given this function is still negative infinity to infinity. And right here, I do see that I get f of 0 equals 1, but now that's going to be a global maximum. The largest output the function gives me is 1 at the ordered pair 0, 1. So when c is equal to 0, the maximum output of the function is the 1. There's no global minimum, because when I look at the function, I see that the limit as x goes to plus or minus infinity of the function. Well, where are those function outputs going to? They're going to negative infinity. So there isn't a smallest output value. When I look at this function right here, I can see that I've defined my interval I a little differently. I'm giving the function from -1, and this is a solid dot, so the -1 is included, all the way up to 2. So x is running from -1 to 2, but I have an open circle here, so the 2 isn't included. And when I look at this function, I still see I have a global minimum here. There is a lowest point on the function. There's a smallest output. So the global minimum is 1. And I get that when f of 0 equals 1. So it happens at the location 0, 1, and the global minimum is 1. There's no global maximum. So here, what you can see is if we take the limit as x goes to 2 from the negative side of the function, we see that it's trying to give us an output of 5. But because I have an open circle, there is no f of 2. F of 2 is undefined. So as we get closer and closer to 2, the function outputs get closer and closer and closer to 5, but they never get to 5. So there is never a largest function output. So there is no global maximum. Here, my function's defined on the open interval from -1 to 2. I still have a global minimum occurring right here, so there is still a global minimum, and it happens at the ordered pair 0, 1, and the global minimum is 1. 1 is the global minimum, so f of 0 equals 1 is the global min, but there is no global maximum. I have an open interval. So here I have what looks like it might want to be a high point on the function. Here I have what looks like what might want to be a high point on the function. So I can see this is definitely higher than this. So if there's going to be a global maximum, it's going to occur right here. But f of 2 is undefined because I have the open interval from -1 to 2 that I'm working over. So I never get the output of 5. It's similar to this example where I just keep getting numbers that are closer and closer and closer to 5, but there's never a largest output. And then here I have an example where there's no global minimum or maximum. So here I've defined the same function, but I've defined it over the interval from -1 to 0, the open interval. I have an open circle here, so we're not including an input of 0, union, and then we're running from 0 to 2. And now 1 isn't a global minimum. So we do see that the limit as x goes to 0 of the function is 1, but the numbers get closer and closer to 1 without ever reaching it. So we get numbers like 1.01, 1.001, 1.0001. The numbers function outputs get closer and closer to 1, but they never get there. So here, because I have open intervals everywhere, I never get a global min or global max. And the last example is this one. This one's actually been defined over the closed interval from -1 to 2, and now I'm going to have a global minimum right here at the low point on the function. The global minimum is f of 0 equals 1. 1 is the global minimum. That's the lowest output I get on the function over this interval that I've defined. But now I'm also going to get a global maximum right here. I see that f of 2 equals 5 is the global max. It's the largest output I get on this function on this closed interval. And the big idea that you want to wrap your head around is that the only place here that I got both a global minimum and a global maximum was the case where I have a closed interval. So the extreme value theorem then comes out of this conversation. The extreme value theorem says, hey, if you define a continuous function over a closed interval, so in this example, we did the closed interval from -1 to 2. If you have a function defined on a closed interval, then there's going to be a smallest and largest output value on that interval. And it's either going to occur at a high or a low point on the function, or it's going to occur at the endpoints of the closed interval. And so in general, if we have a closed interval, so you're working with a function on a closed interval, so we close it off here and here, the extreme values either occur at the endpoints of the closed interval, or they're going to occur at high or low points that occur as you move through that interval. So we're going to be looking for, in the videos to come, we're going to be looking for extreme values over closed intervals. We're going to be using the extreme value theorem. And the idea is going to be to find the extreme value on a closed interval. We're going to be working with closed intervals. We're either going to need to figure out what are the function outputs at the endpoints of the closed interval, and then we're going to need to talk about these points on the interior of the interval where the function may have a high or a low point. And that's going to lead us in the next video to having a conversation about relative extrema, and we're going to need to use the idea of finding relative extrema to be able to find global extrema.